So part 2, we're looking at, let me highlight it in different. Sketch the graph, and again, we're going to get to reference angle later. And then the geometry part, where you're finding the arc length. These are going to be kept exact. So if this question was 138 times pi over, over 180, I'm going to kick you out of your own playroom. That would be 69, and this would be 90. 3 goes into this 23, 3 goes into this 30. So it'd be 23 pi over 30 times 20, and then you can actually cancel those zeros, and I'd get 46 pi over 3. So that's the answer for the arc length. What you're going to do when you type that in would be 46 pi divided by 3. So fill in the blank questions are going to look like that. Overall, you guys did pretty good yesterday on fill in the blank. I would say there was a couple with like spaces that I ended up going back and correcting, but please be careful with that kind of stuff. Okay, no spaces. If it's a square root, it should be square root, parentheses after it. I think, Gianna, you put parentheses around the whole thing. If I remember, you put like if it was 2 square root 3, I think you did it like this, which technically is not wrong. Okay, I just had to go back and change the credit on it. So just do it like this.
If you didn't put the parentheses, did it mark it wrong?
I may have marked it wrong. Like I tried to catch some of them beforehand, and so I gave that option, but it also may have marked it wrong, but then I went back and gave you the credit on it.
Oh, okay, thank you.
Yeah, you're welcome. So I have 2 makeups coming after school today, and then after that I'll actually release the feedback on those quizzes. Most of it doesn't carry over to tomorrow's, like they're completely separate topics. The one that got a lot of you was the right triangle trig word problem, so I'll go over that, but that doesn't pertain to tomorrow's section, so I'll go over it later. But the format overall was pretty good. Like, you guys didn't have too many issues. All right, any questions on those for the first page? Okay, second page. Now we're looking at giving the trig functions. So it's going to ask for a specific trig function. It could be either of these. It could be something, not could be. It will be something that's either bigger than 2 pi or less than 2 pi, so it's not on your original unit circle. So something like this. The even and odd was on yesterday's stuff, so don't worry about that. And then using the calculator to obviously find the trig function, also on yesterday's stuff, so don't worry about that. So it will be more, and it won't ask for 6 parts. It will ask for like maybe 1, like give me the sine of negative 17 pi over 6, something like that. Or the cosine or the tangent. It's only going to ask for 1 of those. Any questions on those? We'll check 4-3. Yeah. All right, so this is the sine of negative 17 pi over 6. First of all, I use the reference angle, which is pi over 6, before I even figure out where it's located. And from there, I know that it's root 3 over 2 and 1/2. And my sine is 1/2. So the value I already know is 1/2. Now all I have to do is figure out what's the positive or negative sign. So if it's 17 pi over 6, I'm going to convert that into a mixed number. This would be 2 and 5/6 pi. But it's negative. So normally, let's say it was a positive 2 and 5/6 pi. Remember, the whole numbers that are even go to the right. So this would go all the way around. This would be 2. And 5/6 is bigger than 1/2, so it's going to cross through that over the vertical line, and it's going to put me into the second quadrant, where cosine's negative, but sine is positive, so it stays a positive 1/2. But again, that's if this angle was positive. It's actually negative, so there's 2 ways to do it. One is work counterclockwise. So counterclockwise means I'm going around to 2 pi this way. 5 pi over 6 is bigger than 1/2, so it pushes it back past the vertical, and it puts me into the third quadrant, where both sine and cosine are negative. So that would be a negative 1/2. The other way to work negative angles is graph it as though it's positive, which we did over here, and then fold it along your x-axis like a hamburger, and wherever it lies, which in that case would be the third quadrant, is where the negative angle is going to be, still resulting in a negative 1/2. So you want to use your reference angles to get the value because it's going to make life easier. And then you want to use the angle, like where it's located on your unit circle, to figure out the positive and negative sign. So you're going to convert it to mixed number and then locate it. Okay, so then for 4, and it's heavy, I would say it's almost heavy 4 just because that's a lot of the stuff that was non-calculator based. This was the same kinds of concepts using the unit circle, which is here. Like, you're going to sketch the standard position and you're going to sketch the reference angle here. Remember that your reference angle has to be acute, well, not acute, less than or equal to 90 degrees. So if I gave you something like 330, which is going to be all the way around in my 4th quadrant, I'm going to find the difference between that and the x-axis, which is 360. So 360 minus 330 gives me a reference angle that's 30 degrees. So my original angle is the one I already drew, and my reference angle is 30 degrees, which is in the 1st quadrant. So this would be theta prime, and this is theta. Theta prime should always be in the 1st quadrant. So if you are graphing that reference angle anywhere else, it's wrong. Okay, your reference angle should always be in the 1st quadrant. If it's one of your 4 pi over 3s, pi over 6, pi over 4, pi over 2, your reference angle is always whatever that pi is over the denominator. So even though this is a negative 9 pi over 4, the reference angle would still be pi over 4. So it's in the top there, but let me redraw it. 9 pi over 4 would be 2 1/4 pi, but it's negative, right? So I'd go negative, which is in this direction. That's negative 2 pi, past it to the 1/4, and that's my original theta. And then the reference angle is going to be pi over 4, which is again in the 1st quadrant. So reference angle always in that 1st quadrant because it's always acute.
Ms. Chris,
yeah.
How did you get like the 1/4? Like,
how did I get, like, when I'm this part or the reference angle part?
In the reference angle.
Okay.
Part. No. Wait, no, scratch that. When you were just like graphing it.
So the 9 over 4 is, like, I actually make it a mixed number. 2 1/4. If it was positive 2 1/4, then my positive angle ends here, right? And then I'd go past it 1/4. So if it was positive 2 1/4, that's where my angle would be. But because it's negative, I move the other direction so that it's there.
Yeah, no, but how do you know like 1/4 is like there?
Oh, I just know like 1/4 is the halfway mark because it would be 45 degrees.
Oh.
So think about your unit circle, right? Close. Your over 6 is going to be the closest one to the x-axis. Then over 4, then over 3, then over 2.
Oh, okay.
So my brain just goes back to that every time.
Okay, thank you.
You're welcome. Okay, that in addition to the graphs are the ones that you're going to have to actually do on your answer sheet, and then you're going to turn that into the separate assignment, okay? 104, 107, you're evaluating without a calculator, so that's from this part too. And then we get into the graphs, okay? All those graphs, which again we'll practice on, so I want you to see it on lockdown what it looks like. That's there.
Number 130.
Okay.
Why does it start on -3 if the amplitude is 3?
Because everything got shifted left pi. So really you're starting up here at 3. And then it goes down and back up again.
Okay.
Does that make sense? You're welcome. What's lockdown? It's an app that locks them into the quiz.
Ms. Schweizer?
Yeah.
I have a question for...
Okay, and then the cotangent and tangents were in 4-6. And then all the stuff here is unit circle based, so that you're going to see. And all the stuff down here is right triangular and inverse. So all that stuff you'll see. The only thing you won't see is like 173 to 174 to 175. That was on yesterday's part. for these, obviously, is definitely pull in your unit circle, or not pull in, but have it printed with, let me get to my, where'd it go? Here. With all those inverse areas marked. So I would say that this is sine and tangent. I would say that this is cosine. I would add on the negative angles. So negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2, because that's going to help you with the sine and tangent. And I would add on the tangents. So 0, root 3 over 3, 1, root 3, undefined. You could go all the way around if you want to with the tangents. Down here, negative root 3 over 3, negative 1, negative root 3, and undefined again. So again, purple is tangent in this case. So I would add all that beforehand. Then when you look at something like A, okay, 168A says arc sine negative 1/2. What this really means is give me the angle in radians that matches where sine is negative 1/2. I'm sorry, sine is negative 1/2. And sine's the y. So because I only use the right side of my circle for sine, I'm just going to look on the right side where y is negative 1/2, and that happens here. So I give that angle, which is negative pi over 6. If you put 11 pi over 6, it's going to be marked wrong. So be careful. You need to restrict that. B is negative root 3 over 2. So if I look back on my unit circle and I find where y is negative root 3 over 2, it happens here. And that angle is negative pi over 3. Go to 169. Cosine now. Root 2 over 2. Cosine, I use the top. So I look, cosine's my x. Where is my x? Positive root 2 over 2. It happens here. That angle is pi over 4. Cosine negative root 3 over 2. I'm looking for where the x is negative root 3 over 2 on the top of my graph, which is here. And that angle is 5 pi over 6. And then the last one is tangent. So tangent root 3, negative root 3, is down here. And that angle is negative pi over 3. Tangent negative 1 of positive 1 is here. And that angle is pi over 4. This was on yesterday's part, so don't worry about the calculator part. But this is the last thing that will also be on tomorrow's part, which is the inverse trig functions using triangles. So use the innermost one. Remember, use this one to set up your triangle. If I'm looking at cosine, this is adjacent. This is hypotenuse. So I put theta in the corner. Adjacent would be 1. Hypotenuse would be 2. I have to use the Pythagorean theorem or my triples. So I would definitely add on my triples somewhere on my notes. 3, 4, 5, 6, 8, 10, 5, 12, 13, 7, 24, 25, 8, 15, 17, 9, 20, 25. Okay. Those I would definitely add somewhere so that you have a quick reference there. This one is not a triple, so I have to do 1 squared plus x squared equals 2 squared. 1 plus x squared would equal 4. X squared would equal 3. And x equals the square root of 3. Now I have my complete triangle. So I go to the trig function on the outside, which is tangent. That's opposite over adjacent. Root 3 over 1, which is root 3. So if I'm going to write that in, it's square root SQRT 3. Overall, yesterday's quiz, you guys did pretty good on the format. Just be really careful. Don't put spaces where you don't need them, okay? I went back through and gave credit if it was like a format issue. I gave credit. Today after school, I have 2 kids coming for my makeup. So after that, I will release the feedback so that you can see it. Nothing really carries over other than just the format, so just pay attention to that. All right, then 183. Again, use the innermost parentheses to draw yourself a triangle. It's cosine again, so adjacent, hypotenuse. I would do 5 squared plus x squared equals 7 squared. 25 plus x squared equals 49. X squared would equal, subtract that, 24. X equals the square root of 24. Oh, that's what we did wrong yesterday. Don't forget that these need to be simplified. So this would be 4 and 6, which becomes 2 root 6. You have to simplify your square roots and your fractions. So theta's here. The last part says sine. Sine is opposite hypotenuse. So 2 root 6 over 7 should be the answer. And I would type that in as 2 square root 6 divided by 7. That's how it's going to look if I were to type that answer in on Canvas. A couple of things I want to point out that are on the module that you need to either look at or you need to grab. Today we're going to actually adjust the iPad settings for anyone that had an issue with loading pictures last time. We think we found the fix, and so I'm going to give you a little bit of a workaround. I'm going to walk you through that process. And then we're going to do some graphing practice to practice the format of the graphs. I'll answer any questions on the PDF, and then I'm going to give you a couple of things that you can do today to help you prepare. So one of the first things is on the module all the way at the bottom. I feel like this is the longest module ever. There is a thing that says, it says Graphing Trig Functions Ibook. There's an iBook there that I built based on, in previous years, I've done a project where they created the graphing, like a how-to graphing book with all the different videos of all the different kinds of trig functions. So that's an iBook. It's like a free iBook. If you want to download it, it's got basically separated by each type of trig function, how to graph it, what to do with a vertical shift, phase shift, all that good stuff. So if you need a little bit of extra practice with your graphs, that's there. Okay. Also, all the way on the bottom, the very last thing says Chapter 4 answer sheet. This is what I want you to download, and you're going to either print this. If you have a printer at home, you're going to print this for tomorrow, or you're going to take a white piece of paper and model it after this so that when you submit your work, it's on something that looks like this, okay? So there's the 3 graphs and then the reference angle graph that we talked about yesterday, which I'll go over again today, and then just space to do your work for the next ones. But that you need to have downloaded because remember, you can't use, you need to have printed, sorry. You can't use your iPad because you're going to be in lockdown, okay? So make sure you get that done today. And then also all the way on the bottom, not all the way on the bottom, about halfway down, there should, where'd it go? Hang on. I got to put it on there. It will be a link to a practice that we're about to do. I thought I put it on there, but let me add it on again. That's going to help you practice the graphing. But before we do that, you're going to have to access that through lockdown. So I want to make sure that we get through the PDF questions first. And then I will have you actually, if you want to jump devices, you can jump devices so that you can do that on lockdown. Test review. Okay, I'm actually going to separate this out by tests and reviews. But it's there. It says chapter, it's today's date, 2.2 practice. And again, it's going to have the graphs that we're going to work on there in a little bit. Okay, that's for today. And then depending on time, I actually have a little Kahoot that we can do to go over the ones that were not on the graphing calculator part. And if we don't have time for that, then I'll just add it onto the module as like a Kahoot challenge. So just keep in mind there's lots of ways for you to practice tonight. Good morning, Christian. Good morning, Andrew. Good morning, Lucy. Good morning. All right, so your order might have been different. I think I randomized the order, so just jump around if that's the case. My first one was y equals 3 sine x minus pi. So my A here is 3. My amplitude, which is something I'm going to enter in, is 3. You'll just do the number. Hang on, I'm frozen. Stop and reshare.
Miss Chris question.
Yep.
If we wanted to see the results from that and to see how like the format was supposed to go, where can we find the results? Would that still be on Canvas, or do we have to go through lockdown?
If you did have to go through lockdown, I'll change it so you can get to it from Canvas. I'll just check that when we're done, Christian. Okay. You're welcome. All right, so that's my amplitude, right? So then the B is 1, and the period also is going to get entered in. That's 2 pi over 1, which is 2 pi. You will enter that in as 2, followed by pi for pi. So this is an answer on Canvas. This is an answer on Canvas. Then it's going to ask for the phase shift, okay? And it is positive pi, which you will enter in as pi. And then it's going to ask for the vertical shift, and there is none this time. So you'll literally just write none. Then on your scrap paper, you're going to find your key points. So I know these because it's 2 pi, right? 2 pi times a fourth times a half times 3/4. We've done this a couple of times. And I get pi over 2, pi, 3 pi over 2. My first one is 0, and my last one is 2 pi, which is the period. Because there's a phase shift this time, I'm going to take that phase shift, which is a positive pi, and I'm going to add it to each of these because it's positive. And I'm going to get pi, this is 2 pi over 2, 3 pi over 2, 2 pi, 2 pi over 2, 5 pi over 2, and 3 pi. And then those 5, it has to be 5 key points. Those 5 key points are going to go on my graph. So I'm going to do pi, 3 pi over 2, 2 pi, 5 pi over 2, and 3 pi. I'm going to mark my amplitude 1, 2, 3, 1, 2, negative 3. And then this is sine. So sine starts at the 0, goes up to the amplitude, back down, and back up again. So I'd start at 0, I'd go up to the 3, down to 0, down to negative 3, back up to 0. And there's my sine curve. There's no vertical shift, so I'm not shifting it. There's no reflection, I'm not flipping it upside down. That is the answer there, okay? One full period on sine and cosine looks like that. Questions on that one? So again, you'll either get sine or cosine. The only difference for cosine would have been I would have started up here, worked my way down, and come back up again. So the actual curve is the difference for sine and cosine. Nothing else would be different.
Where did you get the phase shift again?
It's because there's something inside the parentheses next to the sign. So if there's something inside adding or subtracting from that, then I know there's a phase shift. All right.
How do you know if the phase shift is positive pi or negative?
I take whatever is here and I set it equal to 0 and solve. So I'd get x equals a positive pi. If that number's positive, it goes to the right. If it's negative, it goes to the left.
Oh, okay. Thank you.
You're welcome. All right, then secant, we're going to graph cosine, right? So we're going to do negative 1/2 cosine pi over 4x minus 2. A is a negative 1/2. The negative tells me this is going to be upside down. B, but my amplitude, which is going to be answered on Canvas, is a positive 1/2. So that's an answer on Canvas. The B is pi over 4. So the period is 2 pi over 4. Keep, change, flip. The pi's cancel, and I get a period of 8. Key points. I take 8. I multiply it times a fourth, times a half, times 3/4, and I get 2, 4, 6. First one's 0, last one's 8. Those are my key points, so those go on my graph. My amplitude is 1/2 before the vertical shift. So I'm going to mark that 1/2, negative 1/2. It's also upside down. So I'm going to graph it. I'm going to find my asymptotes and then I do the vertical shift. So remember, I always do the vertical shift. So the vertical shift is -2. That's going to be a blank on canvas. So we want to make sure we do that. And there's no phase shift. So we rate none. The vertical shift you want to do after you find the asymptotes. Because you can't find it. You can't find the asymptotes as easy if you already did the vertical shift. Okay, so I'm going to go to my graph. It's negative cosine that I'm graphing. So I normally would start at positive 1/2, work my way down and come back up again. But because it's a negative cosine, I reverse that order. I start at negative 1/2, go up to 0, up to 1/2, down to 0, and down to negative 1/2. So my curve looks like this. Again, I'm going to find my asymptotes first, and then I'm going to do my vertical shift. So I have to finish these curves because I need 4 asymptotes, 3 curves. Then I would draw my curves bouncing off of those, but before I do that, I want to shift my curve. This is a vertical shift down 2 places. So I'm going to take all of these points and I'm going to shift them down 2 places. So this is at 0. It's going to go down to -2. This is at -1/2. It's going to go down to -2.5. -2. 1.5. -2, 2.5, and -2. So now my curve is here. And the parabolas bounce off that curve. So this is my overall answer. 4 asymptotes, 3 curves.
Miss Chris, for the asymptotes, is it always gonna like the curve switches, or is there like a certain like could we also equation for it, or you just assume
you mean where the asymptotes go?
Yeah,
they always go where my initial curve. That's why we want to do it before we do the vertical shift. Wherever my initial curve hits 0 is where the asymptotes go, because we're flipping that, right? So if that is 0 and I flip it upside down, I do the reciprocal, I'm dividing by 0 and it makes it undefined, and that's what gives you the asymptotes.
Okay, thank you.
You're welcome.
Chris Roger?
Yeah.
I have 2 questions. The highest point on the purple graph in there, what would that be?
Excuse me. That is -1.5. Yeah.
Right, and then we only have to graph the asymptotes on the reciprocal, right? We don't have to graph asymptotes on cosine or sine.
Correct. No, there are no asymptotes on sine and cosine, but they're also going to be on tangent, which I'll do next.
Got it.
Okay, so tangent, my A is -2. My amplitude is 2. Again, an answer that we're going to fill in. My B is pi over 2. The period for tangent and cotangent is pi over B. So this is pi over 2. Keep, change, flip. And I just get 2. Now tangent and cotangent, remember, are different. We do whatever's next to that tangent, the bx minus c, which is pi over 2 equal x. And I set it equal to negative pi over 2 and positive pi over 2 for tangent. That would be 0 and pi for cotangent. So now I divide by pi over 2, which is the same thing as multiplying by 2 over pi. And I get x equals, these all cancel, -1 and +1. Those are my middle 2 asymptotes. From the one on the left, I subtract the period, which was 2. To the one on the right, I add the period. And these are my 4 asymptotes. The way these will be entered in is, again, it will ask for the asymptotes. These are equations, so it will be x equals -3, x equals -1, x equals 1, x equals 3. I also gave you x equals -3, -1, 1, and 3. So one of these ways is how you would enter that in, but it has to have at least one x equals. And it says put it in order from least to greatest. Then I go to my graph, -3, -1, 1, and 3. Those are my asymptotes. I find the zeros exactly halfway between. You will also enter those in. So or actually it says x-intercepts. So you know to put them in coordinate point form. This is -2, 0, and 2. So it'd be -2, 0, 0, 0, and 2, 0. You eyeball the quarter point and the 3/4 point. You mark the amplitude, which is 2. Now, normally, if it's tangent, it goes up to the right and down to the left like that. But this is a negative tangent. So I go up to the left, down to the right, taking on the shape of cotangent. Let me switch these. But obviously not the same as initially cotangent because my asymptotes would be different. Say that these weren't, like, if I didn't know what this point was just by, like, knowing it's in between, I would take these two, add them, and divide by 2. Find the average.
Oh.
So, obviously this would be -3 plus a -1 divided by 2. That's -4 divided by 2, which is -2. But if it was not, let's say it was -4 and 2, you would, -4 and 1, I would add them and divide by 2.
Okay, thank you.
You're welcome.
You would want us to use like if it didn't give a whole number.
If it's like a 0.5, I'll actually give you both.
Okay.
Yeah.
Thank you.
You're welcome.
Chris Spencer?
Yeah.
If not, then I'm Braxton, right?
So like if it was 1/2, you could put 1/2 or 0.5.
But if it was like something else, like if it was more than 0.5.
If it's
then
not,
0.5?
well, it will always be 0.5 because it's always over 2. But if it was in general, like outside of this question, if it was like over 3, I don't want to round a decimal. I want over 3.
Okay.
Yeah.
Thank you.
You're welcome.
Ms. Chris Spencer?
Yeah.
There is no vertical shifts in this one, right?
On this one, no, there was only a vertical shift on number 2.
Thank you.
You're welcome.
Ms. Chris Spencer?
Yep.
So on like lockdown, when I'm writing the x-intercepts, I would write it like
Just like this.
Just like that.
Yep.
Okay, and then
Actually, that's a lie, Jake. I think it says to put a comma between.
I was gonna say like you put a comma in between each of the like.
Yep.
Okay. Thank you.
You're welcome.
Ms. Chris Spencer?
Yep.
What lesson was graphing tan and cotangent?
4-6.
All right, thank you.
You're welcome. Everybody else was good? All right, bye guys. People in school, I'll see you tomorrow in person. Yeah.
Question about going back to school.
Yeah.
If you choose to stay online for second semester, you still go to you still do Zoom with McCarthy, or do you have to go to a different thing?
No, it's the same.
There was a rumor about that. Okay.
No, they're actually sending out a survey and it says live Zoom McCarthy. It's the same.
Thank you.
Yeah. You're welcome.